All right, welcome back. We're on part E of question 2 here, and we're going to solve it using many of the same tools, but it'll wind up working out a little bit differently for a few reasons. We want to do the same thing. We want to solve this for x, which means we either need to combine or eliminate some of these terms so that we only have one x. Now, I have a sine plus a cosine. Wouldn't it be nice if this were sine squared and cosine squared, and then I could combine them with a nice identity? It's not, though. Why don't I try and make it sine squared and cosine squared? That's my first thought. So what I'm going to do is I'm going to take sine of x and cosine of x is equal to root 2. And what I'm going to do is I'm going to multiply each side by itself. Whoa, that's better. I'm going to multiply it by itself. That's basically squaring both sides, but just in long form. So I'll multiply that by itself as well. So this is sine plus cosine squared and root 2 squared. That's a legal maneuver. What that'll allow me to do is put 2 on this side. Root 2 times root 2 is 2. But I can also FOIL what's in here. Sine times sine. So first, outer, inner, last. Sine times sine is sine squared of x. Outer is sine times cosine, so plus sine of x, cosine of x. Inner is cosine of x times sine of x, which is the same thing, because you can do multiplication in any order. So what I have is 2 of these. And then finally, last, cosine of x times itself is cosine squared of x. Now, how does that help me? Well, a couple of things pop out. First and foremost, I have sine of x and cosine, sine squared of x and cosine squared of x, which we know when we add them together, we get 1. So I can replace sine squared of x and cosine squared of x with a plus 1. I'll subtract 1 to the other side, and that'll leave me with 2 sine of x cosine of x is equal to 1. So 2 take 1 is 1. This is one of the double angle theorems. This one is sine of 2x, and that's equal to 1. And so now what I have is one expression with x in it. But the problem is the expression isn't just x. The expression is 2x. We'll see what effect that has. But first, let's see if we can examine what's happening with sine here. We're going to draw in a unit circle. And since the sine of 2x is equal to 1, what we're looking at here is a vertical component all the way up at the top. So the vertical component is all the way up to 1. Now we know that x has to be between 0 and 2 pi. That's what was given to us at the beginning of the question. That's our domain restriction. But we're not really talking about x, we're talking about 2x. What is 2x allowed to be? Well, 2x, if I multiply this whole thing by 2, so let's multiply by 2, what I get is 0 times 2 is 0, x times 2 is 2x, and 2 pi times 2 is 4 pi. What does this mean? This means that if x has to be between 0 and 2 pi, then twice x has to be between 0 and 4 pi. And twice x is what I'm plugging into sine. So twice x is allowed to have 2 full rotations. So that means that twice x can be a number of things. First off is pi on 2. So that's that rotation. But if I'm allowed to go through 2 whole rotations, I hit this angular displacement twice. Once on the first run, once on the second run. So that's pi on 2, 1/2 of pi, 2 halves of pi, 3 halves of pi, 4 halves of pi, 5 halves of pi. So 2x is also equal to 5 halves of pi. So finally, what is x? X is pi on 2 divided by 2, that's pi on 4, and x is equal to 5 pi on 2 divided by 2, that's 5 pi on 4.